All right, we're back. We're on page 178. We're talking about parabolas. So this question says to find like a couple of specific things. We're going to find everything because why would we not? And let's see if we can do it. So we have a focus of 1, 6 and a directrix of y equals -4. So what I'm going to do is start with kind of a picture, I guess. So let's say that this is 1, 6 and that's a focus. So parabola does not go through a focus. None of the conics go through their focus. Parabola goes through the vertex. The vertex kind of feels like the center. It's not really the center because, like, what would the center even mean? And then directrix here, let's do there. And so that's y equals -4. All right, so directly in between the directrix and the focus is the vertex. So if we had a perpendicular line, it would be the midpoint of, or segment, I guess I should say. It's a midpoint of this segment. So definitely x is 1, and then 6 plus -4 is 2 divided by 2 is 1. So we get this. And now the key thing, this is your vertex. It also, now we know what p is. So based on this, p must equal 5. Furthermore, we kind of knew initially, before we even found this, that this thing was going to open up because you never go through the directrix. You always go away from the directrix. So I'm going to just kind of sketch in something here and here, I guess, because the next thing that we want to find, probably based on this, is the endpoint of the lattice rectum. If you plot them, it'll help you to not forget them when you're like listing your things, right? So this one is going to be at 1 plus 5, so 6, 6. And then this is going to be at 1 minus 5, so -4, 6. But when I write them, I'm going to write plus or minus. But, oh, not 5, 10, 2p. Come on. Okay, so 16. So I'm adding 10. I'm subtracting 10. That's kind of interesting. Oh, I'm doing it to the wrong thing. Wheels have come off. It's an unmitigated disaster. Let's see if we can save this video. -9, 6, and then 11, 6. Jeez. All right, do we have everything that we need? I don't know. I'm going to start listing things. Oh, we don't have the equation, but we're going to write the equation right now. All right, so number 1 is the equation. It opens up, so it's going to be x squared. So it's y minus 1 equals, so remember, use the vertex. Maybe I'm reminding myself more than anyone. Use the vertex. You don't use the focus. I screw that up a lot. 1 over 4p, so 1 over 20, and then x minus 1 squared. All right, we have a vertex, which is at 1, 1. We have a focus, which is at, so you're at 1, 1, and you go up p, so 1, 6, which confirms with what was given, but like, work it out. What else we got? We got directrix. I was going to do endpoints, but directrix was given. But if you're at 1, 1, and you move down 5, you get y equals -4, so it confirms it. Endpoints of the lattice rectum, which you can abbreviate like that, are going to be, so you're at the focus, go 2p in either direction, and then the y coordinate's going to be the same. Focal width. So the focal width shows up twice, well, 3 times really, in this information that we're summarizing. So where does it show up? This is 4p. That's the focal width, so it's going to be 20. Also, it's the distance between these. So let's let that fade. The distance between these, so you go 10 in one direction, 10 in the other direction, 20. So, just don't get it wrong, I guess. And then the eccentricity is just 1. Like, it's always going to be 1. So you don't need to worry about that. What can we check on the calculator? Let's see. So go to the calculator page. I'm going to start a new document. Graph. I'm going to graph what I have. So I guess I'm going to switch it to the template for a parabola. What vertex font? We want this one. All right, so it's going to be 1. Nope. 1 over 20, or 1 over 20, and then 1, and then 1, and enter. All right, so let's have it tell us all of the things we need to know. Can it tell us all the things we need to know? Menu 6, option 9, vertex. Click 1, 1. Okay. Menu 6, 9, focus. 1, 6. Good. Menu 6, 9. Let's get the directrix. Down there, -4. What? Click. Menu 6, 9. So I don't know. It doesn't like by default tell us the it doesn't tell us the endpoints of the lattice rectum, but it'll tell us the lattice rectum. So you can do that. Why does that keep happening? I don't know why that keeps happening. Click. It tells us 20. Okay, so that's the focal width. That's good. And then we can actually, if you control click, so control like this, and then click. So I'm going to control click and get coordinates and equations. You can just get these. Control click, and you can see that those are right. So is there any other information we were supposed to get? Endpoints, focal width, directrix, focus, vertex. Perfect. Eccentricity is always going to be 1, so like you don't really need to check that. Where did my, oh, I like zoomed out. Sorry, I was gonna berate the calculator for losing the lattice rectum, but it did not. All right, let's try one more. So this one's gonna be like pretty similar, I think. You just gotta like keep it together, make sure you don't use the focus. Talking more to myself than anyone, but whatever. All right, 1, 6. It's gonna be here, and so that's 1, 6, and that is a focus, right? So lattice rectum goes through there. Don't use it in the equation. And then x equals -5 will be like here. I feel like I used a solid line last time. Yeah, that should be a dotted line. Shall I change it? Let's do one of these, like dot, 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 really dashes. And then there, perfect-ish. All right, midpoint of, I'm gonna draw it in gray. The midpoint of this segment is going to be the vertex. So -5 to 1 is -4, divided by 2 is -2. So our vertex is -2, 6. And you can go 3 in either direction, so P is equal to 3. So now we know that. So P equals 3. So you can kind of like sketch it. You never go through the directrix. So this, we're going to go, 1 is the x coordinate, then you go 2P. So that's 6, so that'll be 12. And then here, we're going to go x is 1, and then 2P is 6, so we'll end up at 0. So I think that's all we need in our graph. And let's do our 7 things. So this is opening not up and down, so it's not x squared. So you know by default it must be y squared. It's going to the right, and that's the positive x-axis, so it's plus. So it's going to be y minus, so the y coordinate of the vertex, so vertex, not the focus. So y minus 6 equals 1 over 4 times p is 12, and then x plus 2 squared. Number 2, the vertex. So the vertex is kind of like the center, but I mean, it doesn't have a center, but it's kind of like the center. Number 3, the focus. Focus was given, but still it's P away, so that makes sense. Directrix is a line. So that's going to be P away from the vertex as well, or 2P away from the focus. So it's going to be x equals -5. Endpoints of the lattice rectum are going to be, you're at the focus, and then you can go 2P in either direction, plus or minus 6. Focal width, which admittedly, you know, so like there are 7 things for an ellipse, a hyperbola, a parabola. Was it a stretch to get to 7 things? I don't know, maybe. I mean, like, you have to throw in the area for the ellipse, which is like, You have to throw in kind of like the focal width or the endpoints of lattice rectum. I feel like that's double the information. But it's useful, but still. So this will be 12. And then eccentricity is always 1. So let's check this on the calculator. So switch over to the calculator. You know, try to race me. Try to check this before I do. So I'm going to put in a new graph page. I'm going to change it. Menu 3, option 2, and then I need this form. Okay, so it's 1/12, and then oh, look at that! I got my equation wrong. Excellent, except for how it's not. I'm gonna swap that up. I'm gonna do it in red. I switched x and y, like some kind of person who does that. So this should be x, and this should be y. Good thing that we checked it. So this will be -2, and then this will be 6 in theory. All right, let's see if it worked, which it should have, but you know, there's no way that's right. Did I then also switch? Oh, chaos. Hold on, I switched everything. This is terrible. +2 -6. All right, this is why we check things. All right, here we go. So this is supposed to be 6. This is supposed to be, whoa, can't delete that. Tab, -2. There, all right. So I could tell like that it was just wrong when I looked at it because of the, did I get everything else wrong then? -2, 1, 6. Possibly I did not. I feel like I should have, except I wasn't really using the equation to find anything. So like, maybe I did myself a favor by doing that. All right, that's good. Menu 6, 9, and then the focus is potentially good, but it's like on top of, yeah, that's good. And then directrix, menu 6, 9, option 5 is at -5. Good. And then I'm going to find the lattice rectum, which is, so it tells you the focal width, and then I'm going to control click to get the coordinates. And then the other one's definitely going to be 1, 0. Well, I say that confidently despite getting everything wrong. Yeah, I think that's definitely 1, 0. Okay, so let me go back and show you what I had messed up, which you probably saw me mess up. And again, that frustrating situation where like, if we were in person in class, everybody would have been like, didn't you switch that? Like no one ever has the confidence to really say it. Yeah, I switched these. Be careful when you're doing them. Hopefully I talked about it right, but I doubt it. But anyway, all right, so I'm gonna, yeah, I'm gonna end this here, come back in the next one, do the next two. The problem is that part D here is like super long. So like it should maybe be its own thing. You know what, let's do this one really quickly and probably get it wrong because we're doing it quickly. Vertex is at -3, 5, that's a vertex, -3, 5. Opens to the left. No, it goes through the vertex. What are you doing? Okay. Focal width is, so that's 4p, is 16, so p is equal to 4. How is that important? That's important in like every way. So I know that if I go 4 units in this direction, I will get to the focus. So this is 4, so this will take me to -7, 5, and that's a focus. And then if I go 8 units this way, right, 2p, that'll take me to one of the endpoints of the lattice rectum. So this is 8, and that'll give me -7, 13. And similarly, if I go 8 this way, -7, -3. And then if I go p units in this direction, this is 4, that's the wrong color, but whatever. It should take me to the directrix, which would be x equals, what did I go? 4, so 1. All right, let's write it up. Let's try not to screw it up. 1, the equation. So x, I think I got that, x plus 3 equals negative because you're opening to the left, 1 over the focal width, y minus 5 squared. Vertex, based on that, is going to be -3, 5. focus. Based on the fact that P is 4 is going to be negative 7, 5. Directrix. Based on the fact that P is 4 is going to be x equals 1. Endpoint. Use the focus. So you're at negative 7, 5 plus or minus 8. Focal width. Width is a hard word. Is going to be 16, which was like literally given, but that's all right. And then eccentricity is always 1. Should we let's go to the calculator really fast and see if we can do it. Sometimes I think that the faster I go, the better I am. That's almost certainly not true, but I'm gonna like stick to that belief. Parabola, I need it to open to the left. Negative 1/16, and then y minus 5, and then so this will be negative 3. So let's find, I don't know, with I guess like everything, vertices or vertex, menu 6, 9, focus, is that negative 7 something 5? I get, oh no, that's like a dumb feature in my opinion, that you can like just grab and change the thing that you graph. Like why would I want to do that? Like I want it to be the one that I thought it was. Menu 6, 9. I feel like if we got the directrix right, then we're probably good to go. I think so. All right, so I'm gonna call that a success. So a little success, a little failure, you know, such is life. Finish up here, and then we'll be back in the next video to do part D. Part D has more answers than you're probably thinking it will, and also there's no chance I'm finding everything for all of them. Just gonna put that out there right now. All right, so I'll be back in the next video. We will try to deal with that, and I will see you there.